Hi there, this is the MSD final presentation for Team 111, which consists of Zain Lee, Gautam Baghel, Amritansh Tripathi, and V. Venkata Sasanka Uppu. So, for the introduction, we are doing a web based plagiarism detection tool. It's a website uploaded at MSD-Team111.com. Plagiarism detection is commonly based on text, tokens, or syntax trees. Usually, people directly copy some text of code in on their own code without proper citation, and that's what we are here to detect. So, proposed detection techniques are based on tokens generated by the compilation of the code and the AST generated when the code is compiled. Plus, it also includes string similarity techniques, which basically compares two strings if they are equal. Tools that we use for this project include Java. Backend framework was Spring Boot and JPA. Frontend frameworks were Angular, JS, Bootstrap, and HTML. Testing framework was JUnit and some other libraries that's listed here. We use database as S2 as it gave a nice little layer over our core database. We use Jira to do our process management systems and raise tickets and issues. Version control was GitHub, and we use Jenkins for continuous integration, and for quality assurance, we use SonarQube's system to detect how much coverage we had and if there were any code smells. Communication was mainly based on Slack.
And the first algorithm we want to talk about is the longest common subsequence with strings. So we break down the codes into a list of words, and we found the longest sequence of the words between two chunk of codes. And we use that to calculate the similarity between the two files. And then we figured this is like a naive algorithm, so we integrate it with AST nodes. So we generate AST nodes from AST trees from both files and pre-order them, and so that we can use longest common subsequence on two list of AST nodes, and it worked way better than the naive version we had for LCS.
Hi, my name is Veera and I'll be continuing with the rest of the algorithms. So the first algorithm I implemented is Descartes similarity. Once the AST is formed for two files which are being compared, we produce hash sets based on AST nodes. And the similarity score is nothing but the union of hash sets by the intersection of the hash sets, which is pretty basic. The second approach is token edit distance. So in this method, we focused on the name tokens. Name tokens can be anything like a variable name, a function name, a string constants, or integer constants occurring throughout the Python file. So once the name tokens are formed for the file 1 and file 2, we calculate the minimum number of edits required to transform the tokens from file 1 to file 2 based on Hungarian algorithm. And we generated a score based on that. And the third approach is machine learning model. So for the machine learning model, we used MOS as an evaluation criteria, and our machine learning algorithm was gradient descent. So we assigned initially weights for each algorithm, and we ran iterations like around 100, and the weights kept on adjusting based on the MOS error output, and that's with the algorithms. And now I'll be going through the system functionality and features. The system has the ability to create a new user as an admin or an instructor. The system also allows the user to create his own credentials and also manage an end-to-end session management. The core functionality of the system is the user can upload multiple submissions and he can also save it in the backend database. So the system can detect plagiarism in multiple Python projects across the submissions, and all kinds of edge cases have been carried. And one of the main functionalities is like the user can select multiple comparison algorithms, and the algorithms are the same which we discussed in the previous slide. So once the selection of the algorithms is done, the similarity score is provided appropriately for all the submissions. And we also discussed about the machine learning model, which is one of the main important features. Another important feature implemented is allowing the user to view a side-by-side comparison with a markup of plagiarized lines. So this allows the user to see where the respective algorithm has picked up plagiarism bits in the code. The system also provides a statistics on number of times each algorithm has been run. And another functionality is the user interface, which is, as discussed in the demo, it's pretty descriptive and user-centric.
Hi, I'm Shin. I'm here to present the process and teamwork. As a team, we follow the agile development process strictly. Before every sprint, we would have an hour to discuss the plan of the sprint to match our requirements. We will list all the tasks we need to do in a spreadsheet and go went through every single one to discuss the job description and the importance for each task. We'll use Jira to set up the tickets and assign them to every single one in our team. Besides that, we will have 5 minutes. We would have 5 minutes check-in every day to talk about uh, what we had done yesterday and what we will do today. At the end of each sprint, we'll double check the features and to make sure they work perfectly, and the codes to make sure they are documented well. And at the end, we will use the Jenkins to build a project, run the test cases, and maintain the code quality with the help of SonarQube. After the after three sprints, we definitely achieved the most of the requirements we set at the beginning of the project. We have used the design patterns we learned from the class and followed the agile development process. Like I said, the systems was tested thoroughly by our test cases. We do have some problems with the development. We had a hard time setting up the Jenkins, and when we were trying to upgrade the Jenkins during the sprint 3, we lost our privileges on the uh, repository as a administrator. So we fixed that with Alex in the end. We definitely should have implemented a complex algorithms to detect various forms of plagiarisms. Um, and what's more, since for each homework we will have multiple submits, and for every submit we would have multiple users with their documents, so it cost us a long time to figure out what's the database and the user and the file management should be.
Hi, my name is Amritan Tripathi, and I'll be talking about job quality and technology transfer. To ensure job quality, we constantly followed good practices. Throughout the duration of the project, we followed a test driven development, and thus each module was thoroughly tested. This is also supported by the SonarQube quality gate, which always passed when our code was built on Jenkins. Also, the code is extensively tested for readability and ease of maintainability. In terms of technology transfer, the system can be easily deployed as a standalone application by following the README documents on GitHub and the setup video. The future scope includes sending email when plagiarism has been triggered in a submission, generating a downloadable PDF report of the comparison result, extending the system to other programming languages as well, and adding more comparison strategies. That's it from Team 111. Thanks for listening.